Alright, Algebra 2. We are in Lesson 11, transforming the graph of the sine function, but we are in part 2. We did quite a few slides already. Took a break because that was 26 minutes, which is a long time, and now we're going to go ahead and finish. Okay, let's look at this example. It wants us to graph the following functions. Let's piece things apart a little bit. Let's look at what omega, h, a, and k are and what they mean. We have a equals 3, which is your amplitude, and how tall things are going to be, and where your maximum and minimums are going to be. The value omega affects the period. So we have omega is 4. So our period is 2 pi over 4, or pi over 2. Okay, the graph of the function is a horizontal scaling of the graph of the sine function by a factor of 1/4. It's 1/4. That right there is 1 over omega. I should write that down, sorry. That's the horizontal scaling. The graph of the function has 4 cycles between 0 and 2 pi. It has 4 cycles. So the things that we've done so far, we know our period, we know the horizontal scaling, we know how many cycles we have between our closed intervals, 0 and 2 pi. What else do we know? The phase shift. Oops. The phase shift is pi over 6. X minus h. So h is pi over 6. We got the amplitude. Well, let's say the phase shift is positive to the right. The midline is y equals k. K in this case is 2. I think we're good. So I'm going to go ahead and draw the midline. Okay, we don't have to draw the midline. What else can I draw? Let's see. We know that we're going to get 4 cycles between 0 and 2 pi. Our amplitude is 3. So if we start at 2, we're going to go up 1, 2, 3. That's going to be our max. Down 1, 2, 3. So that's going to be our amplitude. Okay, let's look at our phase shift. So we're going to go pi over 6, which is positive and to the right. If we see, here's pi over 2, that's 0.5 pi. Pi over 6 is about 0.2. We're going to start somewhere about right there. A little bit of a guesstimate, but it'll be pretty close. Alright, what else do we know? We got our midline, we have our phase shift. Period is pi over 2. We have a horizontal scaling. I think the 4 cycles are going to help us sort of squeeze everything in. To do this well, I really wish I would have had a pencil. So we're trying to get 4 cycles in between pi over 6 to 2 pi over 2. 2 pi plus pi over 6. So you can eyeball it with a pencil. And we're starting up here because we phase shift. So really, you can split this into 4 pieces. Here's 2 pi. So somewhere between, well, if that's 2 pi, hold on. We want 2 pi plus pi over 6. So we need 4 cycles in there. 1, 2. That'll be about it. Those lines shouldn't necessarily be there, but nope. See, I've already messed up. So that'd be 1, 2, 3. Ugh. We're going to make them separate. 1, 2, 3, 4. That last one's terrible. I'm not even hitting my bottom amplitude. So that right there is a pretty close guess as to what your graph should look like. My amplitude is 3. I phase shifted pi over 6 to the right. My midline is at y equals 2. I know my cycles. I should have 4 of them within the closed range. I think I'm good. That was messy. All right. All right. Now, there are 8 of these. I've only left 4 for us to do together, and I might not do all those 4 together. Then the last 4, I just put the answer in from the book, just because that's a lot to do together. So, for each function, indicate the amplitude, frequency, period, phase shift, vertical translation, and equation of the midline. Graph the function together with a graph of the sine function on the same axes. Graph at least one full period for each function. So let's just work through a few of them. Okay, a few of these are going to be easy. Amplitude is 3. Let's see, since omega is 2, we know that our frequency is 2 over 2 pi, or 1 over pi. Therefore, our period is the flip of that, 2 pi over 2, or pi. H is 0, so our phase shift is 0. Yay! So no horizontal translation. K is -1. So our midline is y equals -1. That means we have a vertical translation of 1 unit down in our midline. Okay, so I don't know, for me to sketch it, again, I wish I had a pencil, but it's easy for me to draw the midline and then use that to look at the amplitude, which will be 3 up and 1, 2, 3 down. Okay, our period is pi. That means I'm going to get 1 full cycle between 0 and pi. So I'll need to go up, down, and back. That was terrible. See, this would be easier to do on paper. Up, down, and back. Problem is I'm starting at 0, not my midline. Okay, so that's 1 full period, and we have all the information needed. Not so bad. I could keep going with my circles, with my sine function, but it would look worse. Let's try another one. Okay, by the exercise we did in the first part, you should be able to guess what your graph's going to do. Is it going to stretch, squish, horizontally stretch or squish or compress? You should be able to look at things, and you know, if I have lots of 1/2s, I know what's going to happen. So my graph should look something like what I know it should happen. So amplitude is 1/2. That means it'll be pretty small. Omega equals 1/4. So my frequency is 1/4 over 2 pi, which is 1 over 8 pi. It would help if you could read it. My period is 2 pi over omega, which is 2 pi over 1/4, which is 8 pi. So it's going to be pretty long, right? So since h is negative pi, your phase shift is negative pi. So we are shifting to the left. No vertical translation, k equals 0, so my midline is y equals 0. And I think that's it. So we're staying at the middle. To graph a full period of this function, I can't with the graph they've given me. So that's sort of funny in my mind. But that's all right. So we know what we know. We know that we're phase shifting negative pi. We have a midline at y equals 0. I need to get a full period in 8 pi, so it's going to be really long and stretchy. So what I did is I went ahead and graphed it in Desmos because the graph they left me didn't really help. And you guys are going to ask me in class, can we graph it in Desmos? That's fine, but when you take a test, I'm not going to let you use Desmos. So you need to be able to come up with this and be able to give me some kind of sketch, just not with a given graph by hand. So let me go ahead and bring in the Desmos I did. So what you see in blue is the function y equals sine x. What you see in red is the function given, the g of x given. If you change 8 pi into degrees, you get 1400, 8 times 180 degrees, and that's what you see right there. So we have a maximum at 1/2, a minimum at 1/2, and we shifted negative pi, and again I didn't copy the right thing. Goodness. Hold on, let me erase this. So remember, the period is the measurement from a peak to a peak, or so a maximum to a maximum, or a minimum to a minimum. So if we continued this on from here to here is, which makes sense. Okay, so again, I did graph this using Desmos, but we have all of the information available here to graph it by hand. Okay, all right, this is tons of fun. I'm enjoying this immensely. Amplitude is 5. Our omega is -2, so we just reflected it over the horizontal axis. Okay, we look at the absolute value of the omega to do some math with it. So the frequency is going to be 2 pi omega over 2 pi. So 1 over pi, which is much easier to handle. Therefore, our period is the reciprocal of that, 2 pi over the absolute value of omega. So pi, yay. The fade, h is 0, so we don't have any horizontal translation. is plus 2, so our midline is y equals 2, and then we do reflect over the x-axis. Cool? Alright, so I'm going to go ahead and draw my midline. Y equals 2. Our amplitude is 5, so we're going to be up here. And 2, 4, 5 down there. Our period is pi, so we're going to squeeze everything in between 0 and pi. We don't have a horizontal phase shift, which is good, but we are reflecting it over the x-axis. Let's see if I can draw it. I'm going to go down and up. Not bad. Okay. Sort of get the point. This should be a little clearer over here. But we're at the bottom amplitude, the top. We finish our period in pi, and life is grand. Okay, to measure the peak to the peak, we'd have to go up here. So this right here would be pi. Cool. Okay, D. Oh, our amplitude. But amplitude is always absolute value, so we're at 2. Omega equals 3, so your frequency is 3 over 2 pi. Our period is 2 pi over 3. H is pi over 6. So our phase shift is to the right, translated horizontally. K is 0, so our midline is y equals 0. And we are reflected over the x-axis. Okay, our period of 2 pi over 3. Alright, so our midline is y equals 0. We are phase shifting pi over 6 to the right, so it's a hard one to estimate on this graph. About right there, pi over 6, 1/6 is about 0.2, so pi over 2, that'd be about 0.5, so we're just, a little bit further away from the y-axis. Our period is 2 pi over 3, which is about 120 degrees. But we phase shift pi over 6, so we're going to add 30 degrees to it. So our period is going to be about 150, which will squish it in 150 on this graph. Right about there. We're reflected over the x-axis, so we're going to go down first. Our amplitude is 2, so about right there, and about right there. Yikes. That's awful. Sorry. Okay, if I were me, I'd be eyeballing where my the halfway point between here and then the quarter ways, so that I could get down and up and back again. And I could keep going, knowing that the period right there is 2 pi over 3, which is about 120 degrees. Phew. Alright, these next 4, you can look at the answer and see if you can work through the math. Okay, E, we have amplitude is 3, omega is 1, so our frequency is 1 over 2 pi, our period is 2 pi, H is going to be negative pi, so we shifted to the left by pi. K is 3, so y equals 3 is our midline. Here's the answer. Okay, so what we just did, period's 2 pi, but we shifted it. So if we look from here to here, is 2 pi. Or from here to here. Okay, go ahead and look through it. Push pause, get some details. There's our answer. Okay, see if it makes sense. Okay, our period here is pi over 2. Whoops. So from peak to peak, between pi over 2, of course we have -3. We don't have a phase shift, but our midline is at -3. Amplitude is pretty small. Okay, next. And the answer, A equals pi, so your amplitude is pi. Omega is 1/2, so your frequency is 1 over 4 pi, so your period is 4 pi. Okay, we've stretched everything out. We have one complete cycle in 4 pi, which is pretty stretched out. And your last one. Okay, there we go. Again, we have a pretty big period again. Okay, and here's a good summary. We have our basic equation, how we find amplitude, what we do with omega, what the period, what the frequency is, etc. Okay, that was tough. I hope it makes sense to you guys so we can work through the problem set.